We now evaluate the line integral of this vector field, which is given as f of xyz is given as 2z squared comma 4yz comma yz, and the line is given as it goes from p, the point P, which is 0 comma 0 comma 0, to point Q, which is 4 comma 5 comma 2. So basically we have to evaluate this line integral f dot dr. So let's understand the steps that we are going to perform to evaluate this line integral. The first step that we have to do is we have to parameterize the line or the curve using r of t, where t goes from 0 to 1. And then we have to find out f of r of t. Also, we have to find out r prime of t, which is the derivative of the r of t. And finally, we have to substitute into the formula, that is the line integral formula, which is given here, that is f dot dr. Basically, this is equal to integral of f of r of t dot r prime of t dt. And the integral is from a to b. So these are the few steps that we have to perform to calculate the line integral. Let's now parameterize the given curve, which is basically the line segment which goes from the point P 0, 0, to 4, 5, 2. So we will be utilizing this formula, that is R of t is equal to 1 minus t times of x naught, y naught, z naught plus t times of x1, y1, z1. So this is the formula that we use to parameterize the curve or the line segment which goes from t equal to 0 to 1. So let's substitute the corresponding points. So the point P is considered as x naught, y naught, and z naught, and point Q is considered as x1, y1, and z1. So let's substitute into this r of t. So we'll be getting r of t equals 1 minus t times of x naught, y naught, z naught is basically 0, 0, 0, plus t times of x1, y1, z1 is 4, 5, 2. So when we simplify this, this is all zeros. The first product is all zero, so therefore this becomes 0. And the second product, if we expand the second product, we'll be getting 4t, 5t, comma 2t. So this represents the parameterized form of the given line segment, which is r of t. And this means we have just completed the step 1. Let's now do the step 2, where we have to determine f of r of t as plus r prime of t. So let's copy the f of function. The given function is 2z square comma 4yz comma yz. This is f, and then we'll be tracing this r of t. I'm copying the r of t, which is equivalent to 4t, 5t, and 2t. So basically I have to substitute. This first term represents the x of t, and the second term represents the y of t, and third term is representing the z of t. So in place of z, wherever I have z, I have to replace it as 2t, and wherever I have y, I have to replace it as 5t. So therefore I can write down the f of r of t. This is equivalent to 2 times of z square, which is 2t quantity square, comma 4 times of yz, which is 5t times of z is 2t, comma yz, which is 5t. Let me put it as 5t. Y is 5t multiplied with z is 2t. So let's simplify this. So this will give 2t quantity square is 4t square multiplied with the 2 is 8t square, and then we have 4 times of 5t times 2t. If we multiply the numbers, we get 40, and t times t is t square. And finally, we have 5t times 2t, which is 10t square. So this is basically f of r of t. Now we will also have to calculate the r prime of t, which is basically the derivative of r of t. I'm going to calculate it over here. So this is r prime of t. We have to uh, differentiate each of the terms. So when we do that, differentiation of 4t is 4, differentiation of 5t is 5, and differentiation of 2t with respect to t is 2. So this basically represents this r prime of t. So let me put it here. That is r prime of t is equal to 452. This is 4 comma 5 comma 2. We can also calculate this f of r of t, which we'll be copying into the integral dot product with r prime of t. So let me replace f of r of t, which is 8t squared comma 40t squared comma 10t squared dot with 4 comma 5 comma 2. So in dot product, we just have to multiply and the corresponding components. That is 80 squared has to be multiplied with the 4t, and 40t squared has to be multiplied with the 5, and then 10t squared has to be multiplied with 2, and then we have to add all these quantities. So 80 squared times 4 is 34t squared, and 40t squared times 5 is 200t squared, then 10t squared times 2 is 20t squared. When we add all these things, we'll be getting 254 t square. Let me write down here. This is 254 t square. So basically this quantity which we will require in the integral is equal to 254 t square. Now we have completed the second step. Then we will have to complete the third step. We just have to substitute into the formula as t goes from 0 to 1. So therefore I can write down the line integral as f dot dr. Line integral is equal to f of r of t. This is basically the formula dot with r prime of t dt, and t goes from 0 to 1. So let me replace the f of r of t. We have already computed the dot product, which is 254 t squared. So I can replace this inside part as 254 t squared. T goes from 0 to 1 dt. So let's integrate this. I can factor out the 254, which is a constant, and then integrate only the t squared 0 to 1. Integration of t square is equal to, when we apply the power rule, this will be t power of 2 plus 1, which is 3, divided by the same power, which is 3, and we have to evaluate between the limits 0 to 1. When we substitute the 1, we'll be getting 254 by 3. This will be, when we apply the limits, we'll be getting 1 cube minus 0 cube. So this basically is 1. Can erase this and just put just 1 over here, which means it is 254 only. And when we simplify this using the calculator, we get 84.67. This is approximately 84.67. So this is the line integral of the vector field around the line segment.